Welcome to the General Chemistry 1 class. This section is on mass relationships and chemical reactions, focusing on the reaction yield part 1. In this lesson, we will calculate percent yield and theoretical yield of the reaction. Stoichiometric calculations play an important role in performing chemical experiments, particularly in quantifying the amounts of reactant needed to prepare whenever one is to carry out a given reaction, and determining the expected amount of product given the amount of reactants. The amount of the desired product obtained given a certain amount of reactants referred to the yield of reaction. Theoretical yield is the maximum of the expected amount of product given a certain amount of reactant. This value can be determined from stoichiometric calculations. Actual yield is the actual amount of product gathered from the experiment. The actual yield is usually lower than the theoretical yield due to the number of reasons such as quality of reactants used, other the unforeseen reactions, and errors committed while doing the experiment. With this, efficiency of a chemical reaction is normally expressed in percent yield or ratio of the actual yield to the theoretical yield expressed in percent. Mathematically, percent yield equals actual yield divided by the theoretical yield times 100. Let us have some example. Example number 1. Calcium. Calcium carbonate can be generated via precipitation according to the equation of sodium carbonate plus calcium chloride yields calcium carbonate plus 2 sodium chloride. If 4.163 grams of sodium carbonate was mixed with enough calcium chloride. Question number 1. What is the expected mass of the calcium carbonate that can be produced? Question number 2. Calculate the percent yield given the actual yield, which is 2.54 grams. Solution. The first question is about calculating the theoretical yield of the reaction. To determine this, let us calculate the mass of the calcium carbonate from the mass of sodium carbonate. Notice that the given chemical equation is already balanced, so we can now proceed to the calculation. The mass of calcium carbonate is equal to the given mass of sodium carbonate. 4.163 grams divided by the molar mass of sodium carbonate. 105.99 grams per mole times the mole ratio. 1 mole of calcium carbonate per 1 mole of sodium carbonate times the molar mass of calcium carbonate. 100.09 grams per mole. Simplifying the equation, we can get 3.931 grams of calcium carbonate. For the second problem, the percent yield is equal to the actual yield divided by the theoretical yield times 100. Plugging all the given value of the actual yield, 2.54 grams, the theoretical yield, 3.931 grams, we got from the previous equation, we get a percent yield of 64.6%. Example number 2. Aluminum oxide was prepared by the combustion of the aluminum metal, starting from 12.43 grams of aluminum that was combusted with sufficient oxygen. Question number 1. What is the expected mass of aluminum that can be produced? And 2. Calculate the percent yield of 20.50 grams of aluminum oxide was collected. In solving for the expected mass of aluminum oxide, or the theoretical yield, let us start with checking of the chemical equation. If the chemical equation is balanced, by inspection, we can see that the equation is balanced. For the calculation, theoretical mass of aluminum oxide equals 12.43 grams of aluminum divided by the molar mass of aluminum, 26.93 grams per mole, times the mole ratio 2 moles of aluminum oxide per 4 moles of aluminum, times the molar mass of aluminum oxide, 101.96 grams per mole. Simplifying, we can get 23.49 grams of aluminum oxide. For problem number 2, the percent yield is determined by dividing the actual yield by the theoretical yield, then multiplying the answer by 100. Plugging all the given values, the given 20.50 grams of the actual yield and the calculated value is 23.49 grams as the theoretical yield, we get the answer of 87.27%. To summarize, the percent yield is a measure of how efficient a chemical equation. This value is the ratio of the actual yield and the theoretical yield for calculated, given an amount of reactant expressed in percent. We have here our references or bibliography for further readings. Thank you and God bless.